Good morning all, myself Dr.V.Hari Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In the previous session, we discussed about Unit 4 Energy Sources of Engineering Chemistry that include definition of energy sources, definition of fuel, and then chemical composition of a fuel, and how when it is subjected to combustion reaction, how it involves in a chemical reaction to form desired products, and then calorific value, in how many ways calorific value can be expressed. All these things we discussed in the previous session. So in today's session, we are going to discuss about units of heat energy and in how many ways we are going to express the calorific value of a given fuel sample, and then determination of calorific value of any supplied fuel sample using Dulong's formula, and some problems that were related to determination of calorific value using Dulong's formula. So let us start with units of heat. So calorific value of any fuel, it is expressed in 4 different ways. One is in calories, second one it is kilocalories, third one is British thermal units, and the fourth one is centigrade heat units. So as a whole, a calorific value of any fuel sample that is supplied can be expressed in 4 different ways. That is, units of heat can be expressed in 4 different ways. So let us start with the first one, that is calorie. A calorie can be defined as the amount of heat energy that is required to raise the temperature of 1 gram of water through 1 degree centigrade. That means 1 gram of water sample I have considered, and I just want to raise its temperature to 1 degree centigrade. Say for example, I have considered that water sample, that is 1 gram of water sample, which is at 15 degrees centigrade initially. I just want to raise its temperature, that is from 15 to 16 degrees, only 1 degree centigrade I just want to increase. So for that, how much amount of heat energy it is required? So that is what we call it as calorie. So calorie can be defined as the amount of heat energy that is required to raise the temperature of 1 gram of water through 1 degree centigrade. So let us go with the second type, that is kilocalorie. So kilocalories can be defined as the amount of heat that is required to raise the temperature of 1 kilogram of water. If you notice, in the previous case, that is while defining calorie, we considered only 1 gram of water. So coming to this case, that is kilocalories defining, now we are going to consider 1 kilogram or 1 kg of water. So that makes the difference between calorie and kilocalorie. Except these two, that means amount you are going to consider. Initially it is expressed in grams and now it is expressed in kilograms. So that is the only difference. Now the kilocalorie can be defined as the quantity of heat energy that is required to raise the temperature of 1 kilogram of water through 1 degree centigrade. That means we know very well that 1 kilocalorie it is equal to 1000 calories. So how the kilocalorie can be defined? It is defined as the quantity of heat energy that is required to raise the temperature of 1 kilogram of water through 1 degree centigrade. So let us go with the third type, that is British thermal unit. So it is defined as the quantity of heat energy that is required to raise the temperature of 1 pound of water. So if you notice, now we are going to express the amount of water in terms of 1 pound. So initially we consider 1 gram for calorie and 1 kilogram for kilocalories for expressing the heat energy. Now we are going to consider 1 pound of water. So for increasing or for raising the temperature of 1 pound of water through 1 degree Fahrenheit. So initially we consider 1 degree centigrade raise. So here expressing the temperature also going to change. That means 1 degree Fahrenheit we are going to consider. So British thermal unit can be defined as the quantity of heat energy that is required to raise the temperature of 1 pound of water through 1 degree Fahrenheit. So coming to the fourth one, that is centigrade heat unit. So it is defined as the quantity of heat energy that is required to raise the temperature of same 1 pound of water through 1 degree centigrade. Amount it is same, just like in the British thermal unit, we are going to consider 1 pound of water, but again we came back to that is units of temperature 1 degree centigrade. Initially we used 1 degree Fahrenheit for British thermal unit. Now it is again changed to 1 degree centigrade. So how it can be defined? Centigrade heat unit can be defined as the amount of heat energy that is required to raise the temperature of 1 pound of water through 1 degree centigrade. So if you notice, the interlinking, or we can say how all these four are connected. So that is 1 kilocalorie, it is equal to 3.968 British thermal units, and that is equal to 2.2 centigrade heat unit. So these are the four different units of expressing heat energy that was liberated when a fuel sample it is subjected to complete combustion process or complete heating process. So let us know about some energy facts. So if you notice, on an average I am discussing about, a woman needs 2000 calories of energy for one day. Men needs 2500 calories of energy per one day. 70 kg person, for standing for 1 hour, he or she has to spend approximately 147 calories of energy. If you notice this figure, it is nothing but fried potato chips packet. In this it is mentioned like 28 grams. So 28 grams, by consuming 28 grams of fried potato chips, how much calories of energy we are going to get? That is 160. 160 we are going to get. So after consuming 100 grams, how much we are getting? So it is obtained as 100 into 160 divided by 28. So approximately it is equal to 571 calories. So by consuming 100 grams of fried potato chips, we are able to get 571 calories of energy. See, this is a bucket full of water. That means a bucket it is filled with water. This I just want to heat, and the capacity of that bucket it is able to fill how many liters of water? 15 liters of water it is able to fill. Now what I am going to do is, I just want to heat that water, 15 liters of water. So initially it is at room temperature, that is 25 degrees centigrade. I just want to increase the temperature by 10 degrees centigrade, that is up to 35 degrees centigrade. So initially it is at room temperature 25 degrees centigrade. I just want to enhance the temperature by 10 degrees centigrade. So that is 35 degrees. So this can be done by heating. So for that, how much amount of energy we need? So for heating 15 liters of one bucket of water from 25 degrees to 35 degrees centigrade. So how much amount of energy I just want? See here. Capacity of water it is 15 liters into 10 degrees centigrade rise I want. So that's why in multiplied by 10, and for one bucket we are doing the calculation. So 15 into 10 into 1. So we need almost 50 kilocalories of energy for heating 15 liters of water and increasing its temperature from 25 degrees centigrade to 35 degrees centigrade. Now we are going to know about how to determine the calorific value of a supplied fuel sample. Fuel samples can be solid, liquid or gaseous form, or if you go very deep, we can say volatile, non-volatile, like that also. So basing on that states of matter of the fuel sample that is supplied, we are having three different ways for calculating the calorific value of the fuel sample. So let us see what are those three different ways. The first one, it is bomb calorimeter. Bomb calorimeter is an instrument, that means this comes under practical approach. Bomb calorimeter is an instrument that is meant for finding out calorific value of a solid fuel sample or non-volatile liquids. So for calculating or for determining the calorific value of solid or non-volatile fuel samples, we have to depend upon an instrument called bomb calorimeter. Second one, it is Junkers gas calorimeter. So it is considered or it is meant for gaseous fuels as well as volatile liquids. So for calculating or determining the calorific value of any gaseous fuel that is supplied or any volatile liquid that is supplied, we have to depend upon Junkers gas calorimeter. If you notice, the first two, that means bomb calorimeter and Junkers gas calorimeter, come under instrumental approach, or we can say practical approach. Instrumental method, or we can call it as practical approach. So we have to carry out the experiment and then results that we are going to get are accurate in nature. So that is the advantage of instrumental, or we can say practical approach. So using any one of these two, bomb calorimeter or Junkers gas calorimeter, we can get accurate results for calculating the calorific value of a supplied fuel sample. So if you notice the third type or third approach or third method, that is Dulong's formula. This is purely theoretical approach. Theoretical approach means we will get approximate results for calorific value of the supplied fuel sample. As it is an example for theoretical approach, this can be applicable for any type of fuel sample. That means we can use this Newlong's formula for calculating the calorific value of any supplied solid, liquid or gaseous fuel. So, the first two comes under practical approach or experimental approach, and the third one comes under theoretical approach. So, let us go with theoretical approach, that is Newlong's formula of calorific value determination. So, using Newlong's formula, we are going to calculate the calorific value of any supplied fuel sample, that can be solid, liquid or in gaseous form. Let us see how it is possible. So, this is possible. That means the calorific value of a fuel can be calculated approximately by using Newlong's formula, as I told you, by knowing the chemical composition of the fuel that is supplied. That means the data it is to be given. Using the data, that means the chemical composition of the fuel sample, we are going to calculate. So, what data we need? Percentage of carbon, percentage of hydrogen, percentage of oxygen and percentage of sulfur. In the previous session, we discussed about the chemical composition of any fuel sample. Fuel, if I say any chemical is an example for fuel, it should be highly carbonaceous in nature. That means it should have high content of carbon and second major component as hydrogen, and remaining trace elements be like oxygen and sulfur. So, nitrogen it may be a trace element, but it is considered to be a non-combustible matter. So, nowhere it is responsible for combustion reaction. So, what are the major components? Carbon should be high in percentage and second major component it is hydrogen. So, and trace elements will include oxygen and sulfur. So, let us go with the formula. So, as we know that calorific value can be expressed in two different ways. What are they? One is HCV, or we will call it as GCV, and its full form means higher calorific value or gross calorific value, and second way of expressing the calorific value, it is LCV or NCV. LCV means least calorific value or lower calorific value, or we will call it as net calorific value. So, one formula it is given. How we are going to find out the calorific value, that is HCV of a fuel sample? It is HCV is equal to 1 by 100 into 8080 into percentage of carbon plus 34,500 multiplied by percentage of hydrogen minus percentage of oxygen divided by 8 plus 2240 into percentage of sulfur. We know very well units of expressing calorific value are kilocalories per kg. So, similarly, formula for finding out LCV of a supplied fuel sample, it is equal to HCV minus grams of hydrogen multiplied by 9 multiplied by 587. So, if you notice the formula for HCV calculation, it includes percentage of carbon, percentage of hydrogen, percentage of oxygen and percentage of sulfur. That means this data it is to be given, then only we can substitute and calculate the calorific value of the supplied fuel sample. And the next one, it is LCV. Considering the definition of LCV, how we can define LCV? The amount of heat energy that is liberated when, if any fuel it is burnt in excess of air, completely in excess of air, then the products of the combustion reaction are allowed to escape. That means we are not going to consider the heat energy that is liberated due to the products also. So, if you notice the combustion reaction of any fuel sample that was discussed in the previous session, so we will get CO2 and H2O in the form of water vapor as products. So, carbon it is responsible for releasing or liberating CO2 during the combustion of a fuel sample, and hydrogen it is purely responsible for releasing water vapor during the combustion reaction along with the heat energy. Okay. So, that is why if you notice the LCV formula, as we are telling that the products of combustion reaction are to be escaped, that is why we have to deduct. HCV is accounting for all the combustion products. That means according to its definition, we will consider the heat energy that is produced by the combustion products also. So, that is why HCV it is to be deducted from that heat energy produced from combustion products. So, if you notice the formula, LCV it is equal to HCV minus grams of hydrogen into 9 into 587. So, what is this 587? So, this is what we call it as latent heat of condensation. Latent heat of condensation of what? Water vapor. Because we are getting, because of combustion reaction of hydrogen, we are getting water as a one of the products. So, latent heat of condensation of water vapor we have to use in the LCV formula. How we can define latent heat of condensation? The amount of heat energy that is produced or generated when water vapor involves in condensation to convert to liquid. That means change of state from vapor to liquid. So, that amount that is generated during this condensation process is what we call as latent heat of condensation. Latent heat of condensation. So, here I am going to explain you about how this 9 and grams of hydrogen we are going to consider in formula of LCV. If you notice the combustion reaction of hydrogen, that means when a fuel it is subjected to combustion reaction in excess of air. So, carbon we know very well it is able to liberate CO2. So, that is first reaction. Coming to the case of hydrogen. So, here we are going to consider 2 moles of hydrogen. If 2 moles of hydrogen it is subjected to combustion reaction, it is able to generate 18 moles of water, H2O. So, that means if you notice 2 moles, if you consider 2 moles of hydrogen and subjected to combustion reaction, it is able to generate 18 moles of water. For 1 mole I just want. So, how it will be? So, 1 into 18 by 2. So, we are getting 9. So, if 1 mole of hydrogen it is subjected to combustion reaction, we are able to get 9 moles of water. So, as we are considering percentage, as we are always considering percentage of chemical composition of fuel sample, we need to convert this 9 in terms of percentage. That is why it will become as 9 by 100. So, we are getting 0.09, that is hydrogen percentage. So, that is why we are going to incorporate 0.09 percentage of H into 587. So, this 587 as I told you it is latent heat of condensation. If you notice the formula for HCV, it includes 1 by 100 into 8080 into percentage of carbon plus 34,500 into percentage of H minus percentage of oxygen divided by 8 plus 2240 into percentage of sulfur, kilocalories per kg. So, this is the formula we are going to use now for problematic part, and similarly for LCV we are going to consider this formula. LCV is equal to HCV minus 0.09 into percentage of H into 587 kilocalories per kg. So, this 587 it is what we call as latent heat of condensation, and then this 0.09 how we are going to calculate I explained just now. Thank you so much.